Hello there, CP Finite. Welcome to lesson 2.4. Today, how do you write and graph linear inequalities? Write an inequality that represents the following scenarios. Inequalities are something that really are rather applicable in life. You may not recognize it, but in many scenarios, such as you must be at least 52 inches tall to ride Skyrush, that is kind of like an inequality. So remember, if you see something like at least, okay, what we would be looking at here is that your height, okay, if you are about to ride Skyrush, must be greater than or equal to 52 inches, okay? So you might say something like h must be greater than or equal to 52. So inequalities, remember, what are inequalities? Those are things like less than, greater than, well, actually, this is greater, and this is less, and then greater than or equal to, and less than or equal to. You can spend up to $25. So the amount you can spend would have to be less than or equal to 25. If you only have $25 in your pocket and no way to withdraw more money, then you're going to have to spend less than or equal to that there. You must be at least 18 years old to play the lottery. So hopefully you're getting the hang of this. That just means your age would have to be greater than or equal to 18. And for other things, you're allowed to invite between 4 and 10 friends to a party, especially important nowadays with limitations on parties and everything. So if it's between 4 and 10, that means your number of guests can be greater than 4 or equal to, and less than or equal to 10. So these are examples of inequalities that we're looking at. Guests under the age of 12 get in for free. So once again, age would have to be less than or equal to 12. Okay? Where this gets a little more interesting is when we are sketching graphs of each linear inequality. So remember, with inequalities, you have to decide on two things. It's a line type and where to shade the graphs. For line type, you are going to use a dotted line. So a dotted line if it is a greater than or a less than sign. You're going to attach points with a solid line if there's the equal to or less than or equal to, greater than or less than or equal to. Okay, that's your first decision. Shading, I will show you a little trick for that when we get into it. Now, other than that, it's really the same thing about graphing that you did in Unit 1. So remember, there's our y-intercept. So at 1, we have a slope of -3/2, 1, 2, 3, 1, 2. Or up, 1, 2, 3, 1, 2. And first thing we need to decide is line type. Well, we have strictly less than, so it's going to be a dotted line. So I'm going to connect these points best I can with a dotted line. Not the prettiest, but you get the idea. And the last part is decide where to shade. So are we going to shade above or are we going to shade below? Where do the solutions lie? One method that I always recommend is known as the test point method. Test a point. And you can test a point not on the line. So test any old point that's not on the line. So when I say test a point, you could test this one, you could test this one, anything that's not on the formal line of our equation. Usually the easiest point, as long as it's not on your line, is 0, 0. Always try that one out. Now, when you're testing the point, so when I test 0, 0, what that means is I'm going to substitute that into my equation. 0 is y and x. So I'm asking myself, is 0 greater than negative 3 halves times 0 plus 1? And you just kind of start to fill out that negative 3 halves times 0. And is 0 greater than 1? No, it is not. So here, again, is where 0, 0 is. Since that's false, that means we want to shade everything on the other side of the line. So since 0, 0 is not true, we're going to shade in this here. Just to show you, had you picked this point here, so had we picked 5, 5, 5, 5, and you only need to pick one test point, but we would have is 5 greater than negative 3 halves times 5 plus 1, and that would simplify to 5 greater than, using my calculator here real quick, negative 7.5 plus 1, and 5 certainly is greater than negative 6.5. So see how that's true, and that is why it's in the shaded region. These are all solutions. All these points that are shaded are solutions. Okay, so that's the idea of a test point. And that's really going to be the best algebraic way to do it. So we dotted the line, we shaded, we're ready to move on. For number 7, okay, use some other graphing techniques. You might want to get into y equals first. So for y is less than or equal to negative 3x plus 20. And dividing by 4, divide by 4, that means y is less than or equal to negative 3/4 x plus 5. Okay, thing to decide first, we're going to need a solid line. Solid line because it's less than or equal to, and we'll start at 5. We have our slope negative 3/4, 1, 2, 3, 1, 2, 3, 4. And this time connect with a solid line. Okay. The difference between a solid and dashed line is for a solid line, these solutions are included. So the line are solutions. Okay, if that's the proper way to put it. In the dotted line, these are not solutions on the dotted line. Okay, it's not including anything, but for a solid line, it is. So we graphed it. Now we just need a good old test point. And the best one to do, again, we could test out 0, 0. It's going to be very nice for us. And you can even substitute into the original equation. So 3 times 0 plus 4 times 0, is that less than or equal to 20? And 3 times 0 plus 4 times 0 is just 0. That's why it's an easy point to pick. And 0 is less than or equal to 20. So again, that's the point we tested. It is true, so we want to include that in our shading. Okay, so that is where we would shade. Alrighty, so line type and all that. Now applying that to systems, and we're going to do some word problems in the future with these. With systems of inequalities, it's really just graphing, so don't let it scare you. But you want to focus on each individually. So I'm going to graph the red equation here first. So y-intercept at 7, slope of negative 3/8, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And a solid line because it's equal to. Now do the whole thing. So also decide where to shade. Also, little trick here, shortcut time, shortcut. As long as it's solved for y, so it has to be solved for y. If it's greater than, you're going to shade above. If it's less than, it's always going to be below. So you can certainly do the test point method still, but for a shortcut with that, it's greater than, it's solved for y, has to be solved for y, and then we will just shade above. So now as we're shading this, just kind of do it lightly. Just give yourself an idea, and it's going to be shaded above. Again, you can use a test point, and you'll find it'll work out as well. Now, for the other equation, I'm going to use blue. So we just move on to the next one, -1, slope of positive 5/8. Yes, they intersect there. That's really not all that important this time around. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And the best we can, a dashed line. Why is it dashed? Because it's not equal to, Mr. Dvorsky. I'm sure you all said that along with me. And so we're going to use our little shortcut. It has to be solved for y, it is. And we're going to shade above. So we just have lines above here. Happy shading. Happy shading. Now, notice this phenomenon here. We have an area that's double shaded, and that's very important because that is actually the true solutions. So this section where everything overlaps, those are the true solutions. Okay? So those points satisfy each equation. Okay? So make sure that when you're doing these, that you really specify. If you want to erase the other dashes, okay, you can do that. But if you don't, that's okay. But just make sure you specify the true solutions there. Sometimes it does help me grading as far as if you erase or not. So it does not really matter, but make sure you get that part highlighted for me. So moving on, another just example here. We'll see something a little different. So up 7, 13/5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5. Whew. And it's going to be a dotted line. Going to try and do the best I can here. And shading above. So it's actually going to be above that line. Now for the other one, so this time at -5, it has the same slope, so that should be something interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13. 1, 2, 3, 4, 5. Another dotted line. And this time it's shaded below. What in the world's going on here? No, we didn't do anything wrong, but notice how there is no overlapping shading. So none of the shading overlaps, which then means there are no solutions. Okay? What I like to think of as this is a no man's land type thing. So there are no solutions. And that's going to happen if you have parallel lines and the shading is going in opposite directions. So that's a fancy example of no solutions. Again, if it's less than, it's below. Okay. Last example. Just be aware of some horizontal vertical line stuff coming back. Remember, this is a horizontal line. Horizontal. And if it's y less than or equal to 4, then we're just going right through 4 horizontal line. Now, sometimes inequalities confuse students when it's just y is less than. So think, it wants y less than or equal to 4. Well, what numbers are less than or equal to 4? that would be 3, 2, 1, 0, so forth. And where are those on the y-axis? Well, here's 3, here's 2, here's 1, 0. So that means we're going to shade below. Okay. Greater than 3x plus 1. So if we have our y-intercept at 1, and we are rising 3 over 1, 1, 2, 3 over 1, we're going to use a dotted line. Hopefully you're getting the hang of that best you can. And shading above. So I'm using that little shortcut. It's going to be above. So right up in here. Oop, I know I went over the line, but it's okay. Now I'm actually going to throw in one more equation here. Oh man, we're going to throw in x is greater than -6. Going to throw that in there. You might see 3, you might see 4. Don't let it scare you. Now x greater than -6, that's, remember, a vertical line. So -6, and I'll make it less than or equal to. How about that? -6, that way we can use a solid line here. Or greater than or equal to. And again, sometimes students aren't quite sure where to solve, so think. We want x bigger. We want x to be bigger than -6. Well, what values are those? Those are things like -5, -4, 0, 3. And all those values are to the right. To the right here. So we have a lot of shading going on, a lot of different shapes. This is why it's important not to go too crazy with your shading. And notice where all three things come together, this little triangle pocket would be our solutions. Okay, so graphing with shading, graphing more than one thing at a time. You guys can handle this. Make sure you work on the practice problems, and great job, everybody.